Our top story, there's been a failure of ISRO's latest rocket, the GSLV, the second consecutive failure of the GSLV rocket system. The blast-off took place shortly after 4 this afternoon, and as you can see there, ended catastrophically. That explosion taking place approximately a minute after blast-off. It was a failure of the first stage of the multi-stage rocket system which resulted in this failure. The last GSLV, which was tested in April this year, also failed. 3 of 7 GSLV rockets have failed so far. It's a significant setback for the Indian Space Research Organization and a complete contrast to the remarkable success that ISRO has achieved with its other rocket system, the Polar Satellite Launch Vehicle system, which has had more than a dozen consecutive successful launches. What this essentially means is that India's ability to put heavier payloads into space, whether satellites or in fact even a manned mission to space, is now seriously in question, because more than anything else these rocket systems have to be as reliable as possible, and presently there are recurring problems with the GSLV system. It should be mentioned that if there was a first stage failure of the GSLV rocket, then that's something which a lot of people would say is completely unexpected, because the first stage is a proven system. The first stage, which propels the rocket to a certain altitude, has been tested repeatedly on the PSLV system. In fact, it's essentially the same system which does duty on the GSLV as well. Also, in the last test, there was a failure of the Indian-designed cryogenic engine, which is an upper stage motor, but in a sense one of the most critical technologies that go into the GSLV. But on this particular occasion, initial indicators are that cryogenic stage hadn't been fired. It was a lower stage failure, which was an Indian system which failed, because that cryogenic system, the cryogenic motor in today's launch, was a Russian one. NDTV science editor Pallav Bagda, one of India's leading observers of the space program, actually joins us on the phone line. He joins us from the United States. Pallav, any word, any details you're getting?
No, I haven't gotten further details except to know that it's the first stage where the failure happened, and that the cryogenic engine has not kicked in at all. So we should not be talking at all of the cryogenic engine stage. Remember, the first stage is a 2-part rocket motor. One is a big solid booster, which is over 100 ton of fuel, which has attached to it 4 strap-on boosters, which are essentially engines which are used in the PSLV. So these are both very tried and tested rocket motors. Now, what has gone wrong in this particular motor is one will have to wait and watch. I distinctly remember there was an earlier failure of the GSLV where there were plumbing issues in one of the strap-on boosters, because of which the rocket had to be exploded mid-air. It had to be self-detonated. There is a mechanism. Remember, a rocket which has deviated from its path is like an unguided missile, and ISRO does not want an unguided missile going anywhere, so they have a detonation mechanism on it, and they detonate the vehicle so that instead of going up, it goes down into the sea safely. So that is what probably has kicked in, but that the failure has happened in the first stage is a significant fact. That the cryogenic engine was where most troubles are expected, and the first stage was a tried and tested area of the rocket where the failure has happened. It happened within the first couple of minutes of the launch itself, is something which will bother ISRO scientists, because this is a tried and tested area of the rocket.
What are the implications for future missions of ISRO which were planned around this system?
Several. See, this is India's heavier rocket vehicle. This is meant essentially to launch 2-ton plus class of satellites into the geosynchronous orbit, which is the 36,000 kilometer Earth orbit. This is also the vehicle which India was planning to use for its second mission to the moon, Chandrayaan-2, which was to be launched in a year or 2 from now. This is also the vehicle, the GSLV, a variant of which, a larger version of this, is what India was wanting to use for its manned space program, which has not yet been announced but is on the drawing board. So there are several areas where ISRO will have a setback, and that out of 7 or 8 launches, more than half have failed for GSLV. is an issue which will bother ISRO scientists. But most scientists at ISRO learn from failures and they go ahead. The first few flights of PSLV were a distinct learning curve. So same thing is probably happening in the GSLV program, where the scientists are learning newer and newer things, and failures become stepping stones to success.
Pallav, this last point is a bit of a disappointment to a lot of us following the Indian space program, simply because in many areas ISRO is ahead of the learning curve. In the PSLV, it's been remarkably successful in terms of the launches that it's had. In satellites, it's been in many senses a world beater. But this is a reality check and very much in line with the series of failures that the United States, the former Soviet Union, even countries like China have had in their space programs.
Oh, Japan also had series of failures in their heavier rocket launch vehicles. Remember, there are not many nations which do heavy rocket fairing. India is in a distinct club of 5 or 6 nations which sends rockets high into the geosynchronous satellite orbit. So it is a risky business and it is a setback for ISRO, but I'm sure they would be able to learn and move ahead. Remember, in the Polar Satellite Launch Vehicle program, India learned very quickly what was going wrong and then succeeded.